Hello everyone, welcome back to ABI-DOS. In the last episode, I spent around an hour, I think, on Alternator, and I had the idea, I feel like a general algorithm that was about right, but I didn't get all the timing worked out and the details, and I just didn't want to spend a bunch more time on it. So, the game permits you to skip some puzzles. Maybe I'll fix this one off camera, maybe not, who knows. Probably what I'll do is when I run out of skips, I'll just stop playing and I'll say, that's your game design problem, let me do what I want. And I would play your game longer. But then I went and did linked list, which was on camera, but my computer secretly restarted, as Windows likes to do. And one of the things that rarely, not never, but not always, happens when the computer reboots is that OBS gets messed up and forgets which sound device to use for my mic, and it just decides to use a sound device that's not anything. It's just a sound device that never produces any sound. So I solved linked list off camera, and we'll do a little tour of it here before we start the next puzzle, I guess. The idea of this one was that input 1 is a linked list, a set of pairs in kind of the Lisp, cons, car, and coulter tradition. Or really, any linked list is implemented this way, but it's very explicit with cons cells. They're pairs where the first item is another offset and the car. No, actually it's the coulter is first. It's a little weird, but whatever. And the car is a value. And so this is a cell saying the value is 168 green, and all the values here are green, so I won't mention that. And the next pointer is 2, which is here. And so if we wanted to traverse from here, well, the value of that cell is 111, i.e. a green L, and its next pointer is 108, which is over here. So there the value is T, and its next pointer is 34, which is, I don't know, around here? Yeah. So then this is basically one big linked list. And this input tells you, okay, what's the 1th element of the list, i.e. traverse the next pointer once and then produce the value you find. This one says traverse the next pointer 2 times, always starting from the beginning, so resetting each time. This one says traverse the next pointer 3 times and produce the value you find. So that's the idea. And this is what I wound up with. There's a few idiosyncrasies here, like we add 1 and then subtract 1, which looks a bit silly. But it has to do with how this loop is structured, the main loop that... what? Get out of here. No, not pause. Stop. Didn't mean to start it. Stop. Why is... Okay. You kind of need to do these 4 operations in your loop. Test for 0, subtract 1, get a new input, and then a conveyor to make you stay in the loop. So this is the smallest loop you can make. And the problem was I wanted this request input. At first, I had it out here because, sure, you need a new input, right? From this screen, from the list. But then you end up requesting an input even when you're supposed to traverse 0 times, and I was left with some junk, I needed to throw away this 2 and then request the value that was there, and that kind of stinks. So maybe there was a way I could have structured this loop better, I don't know, start it here or something. It seems like I should have been able to do this. I don't know why I didn't. This looks way better, in fact. But I think if I just make this change, it'll mess up the timing. Let's find out. Actually, no. It looks great. Nope. There they are. 8 errors. See? So some of these were wrong because we started doing this part before we were ready with the cleanup from the last bit, basically. So I don't remember, I don't want to go through the details of exactly how I could do all that. So instead, I add 1, This still doesn't make a lot of sense, does it? Wouldn't like this be equivalent, but less confusing? It's just a little delay here. Yes. So that'll save me an icon compared to what I did before. Okay, that's a little simplification. Oops, I didn't really need to exit. And I think if I just swapped these two, I could put this closer. Do my cleanup in a different order here. Does that actually work? It looks that way. Yeah, we're going through whole test cases. All right. So that's a tiny simplification. Oh, and it tells you which... That's nice. Cycles used for average calculation in your... Huh. So it calculates your average, I guess. And says this is the one that was slowest. Fine, I assume it had the largest numbers in it. So we shaved off an icon that way. So anyway, there's this loop here. And when we exit the loop, because we detected a 0, first we increase the pointer here, saying don't actually request a bit from this, just skip it a bit. And so we, here, I mean, you can see. Now this is 0, so we say, okay, I'm pointing at the right list, but I'm at the wrong part of it. I'm pointing at just the address. So skip that, and then ask for a new bit from here. That's the value we want to produce. And this conveyor, which is off by default, so that the bits we ask for go this way normally. Is currently turned on because of this comparison here. And what it does is it says, instead of using this to adjust the pointer of signal 1 and then throw it away, this needs to go to the output. So first, on its way to the output, it does some cleanup. It sends a B here, which just spawns a U-bit that is going to go reset the pointer on this signal to 0. And it also resets... I think it does a little bit more than it has to, but it's fine. The important thing is that it turns this conveyor back off, so that the 0 can make it to here. And then it requests a new input for this, and we're off to the races. But this A... Oh, right. It looks like it's doing more than it needs to, because it like connects to this, and like, why bother, right? Actually, I guess I could do this instead. Actually, I could use less... use fewer spaces by doing this, could I not? I think so. This space now doesn't count. Is that still right? Looks good. Okay, cool. So this A takes a very long route to get to here, but the point is that I need it to not be wired up to this B. Actually, it would probably be fine if it were. No, because then this B would be wired up to whatever this A is wired up to, and I don't want that. Do I? I don't know. Anyway, this is fine. Is there some way to trim this out, this space here? It feels like there should be. I mean, obviously we could trim a lot of space because the goal is to do this. I'm actually really close. I didn't realize. Like, if I rotated this thing 180 degrees, it would be these 6 spaces I'm not allowed to use, right? And so I wouldn't quite be there, but it's close. Interesting. Okay. I thought I had made kind of a mess, but it turns out it's nicer than I thought. Anyway, let's hit go one more time and go look at the scores again. U-bit number? Oh, there are like 2 U-bits in the system? That's interesting. Okay, so that was linked list, which I recorded, but it didn't get published because of the sound issues. What are A and B? Oh, array slot and array score. Interesting. Yeah, I don't need hermit mode. And friends, look at that. I don't have any. Okay, so channeler for today's. What's channeler all about? This program redirects data between destinations based on the state of a 2-part gate. 0 is characters, 1 is coordinates. 2 and 3 indicate the state of a gate made of color pixels, which can be red or green. What are you talking about? Okay, I see there are reds and greens. Read a character and a coordinate. If they're both green at the coordinate, send the character to S5 at that coordinate. If false, disregard it and send a red hash. I see. So what is this they've decided I might want? A nullifier? Disable it temporarily. Yeah, I saw that one before, but never quite saw a reason to use it. So the states on this thing are active and inactive, I suppose? Yes, okay. 4 inputs. Now, by the way, I'm looking at all of the parts available to me, and this looks like it is all of them. Some of them are not recommended, but like you can see what they all look like. And that's interesting because I know on the Steam store page there's an image of gameplay with a kind of icon I've never seen. I think I called them ports, they're icons. It looked like a grid of, like a 4x4 grid of dots. I don't see that on any of these. Huh. I thought, oh, let's keep playing at least until I see what that thing's about. Maybe it doesn't exist anymore? Maybe you gotta get into super cool mode to play it? I don't know. So, I guess we might want the nullifier. To kind of avoid needing conveyors, in a way. You could do a more kind of straight line. Although I don't quite see how. S0 is the coordinates? No, S1 is the coordinates. So I can tell you one thing we're going to have to do. Is this. We may decide to reorient these or fold them up a little bit, but we have to set coordinates for three. Yeah, we're not setting them for S1, right? Yeah. But for 2 and 3 and 5, we have to set the coordinate we're going to do something at. So, I mean, it looks sort of like this. Maybe we would request a new bit here, but probably not. So, I mean, honestly, that could just be its own thing. Maybe we would do better to, like, I don't know. I mean, the game does not make it easy at all. I don't mean like, oh, it's how nice a challenge. I mean, ergonomically, it's very unpleasant to try to fit stuff into this grid. Because you, like, design things, and then you're like, okay, fine. But, like, it turns out the way you did it, it's like the right shape, but rotated by 90 degrees. And the game's just like, fuck you. Like, I'm not going to help you rotate things. Do it yourself. And it's a nightmare. It's so hard. So I'm just like, I'm not that bothered by getting this. Getting the challenge mode stuff. If the game hates me, then that's life. I'm just not gonna do it. So S1 is coordinates, right? Actually, I think, well, we should do 0 last. Or maybe like this? Yeah. Because what I kind of want is something where we have like I'm supposed to check if I need a color sensor. I was gonna just have one conveyor, but you can't quite do that, can you? Well, actually, maybe you can. Because you can't just have a color sensor that says, oh, you know, I was thinking, let's put something here and, you know, check if it's green. And if so, like, I'll have a conveyor somewhere and I'll turn that conveyor off so it can keep going straight. Something like that. And then I'll use the same conveyor. I'll also use the same color sensor because I'm checking the same color for both of these, right? Why not use the same color sensor? The problem is because it would overwrite what the other one had written, right? But actually, if I do this, request 3 before 2, they'll merge when they get here. And then I can actually say, is the color green? If so, they must have both been green. Otherwise, it'll be either red or magenta, right? And one of them will have made it non-green, and this will be going to A. Okay, I like that. So I'm going to need a recycler for these guys, and I need a recycler for this as well. Maybe I could reuse this recycler, squeeze it in somewhere. All right, let's actually put this back on and think about things like in that way for a moment. What if I did this? Just let me rotate, man. You're the computer. I'm just a person, and rotating sucks. I have very little going on right now. It's not that hard to rotate. I can do it, but it makes me mad that you make me do it when it would be so easy for you. So my thinking is, this bit will get here at the same time this bit gets here, according to the way these are wired up. Which means we can use a conveyor B if they are both green. I wanna, like, I don't know. It's still not easy to fit in here. I'm sure it would be if I could just like rotate. I want to put down the logic and then rotate it like Tetris blocks, but it's so hard to rotate that I don't want to do that actually. Because these guys have to go to a recycler, and so does this. Here's an idea. Maybe what I can do is this. So I was trying to construct something like this, where could I actually make even more space this way? So the conveyor's pointing the wrong way. But if I make this the default direction... Oh, which one do I want? Here, okay. So 3 and then 2. Okay. And right here is where I can detect that we're creating some trash. And that is the perfect opportunity for a universal B sensor to produce the red hash from somewhere else and then get it onto this little jolly trail, I guess. Okay, so yeah, this is looking really nice, I think. What do I want this active by default or not? If these are both green, I want the conveyor to be on so that we do not go into Trashville. which means its default state should be off. And then when I detect green, we turn it on and go this way. Okay, great. Now we need to wire that up before I forget, as I usually do, and avoid this universal B sensor, which is going to go somewhere else. I think here, in fact. Not quite. It's going to go... I need port Y, a definer, and a colorizer for red. Now, I could do this and just put an unconditional conveyor in here so that they both join up, and then I like ask for an input from 1. Oh. Shoot, I need to do more than this. I'm setting the pointers for all of these things, but I'm not reading from them. Blah. Oh man, I thought it was looking so nice. It could still be salvageable to fit within this space. So we can do this now. The problem is... am I really ready to read an input from 0... from all 4 inputs? Because that would be really nice, wouldn't it? If I could just put a request input from everything here. Instead of having to put request input from 3 different things. Putting this here is a problem. They merge correctly, but then it bounces around. To get them to line up properly on the same thing at the same tick, I either need them to merge, join the same path, which is possible, but difficult to fit into this shape, I feel like. Or I need to request them at offset times, which would mean multiple inputs, like 3 of them. Which means it would be really hard to fit all this together in the space provided for a challenge mode. Or... actually, I mean, maybe I could just let this input bounce off of here. No problem, right? Maybe? Maybe no problem? I think it'll take, like, my throughput's not going to be so high that this bounces into, this collides with the next bit, I hope. No, it won't be, I don't think. I mean, I guess it would be if I put a request all inputs right after this, I think. Let's see what that would look like. Let's put this here. and just step a bit. This one has to be inactive, though. No. Yeah, because I'm not ready to read the character. Wait, I'm not even supposed to set this. Right? S0 is characters. Yeah, I shouldn't be setting its pointer. I just read them sequentially. Okay, so it looks more like this. This has got to be too fast, right? But let's say it weren't. Maybe it's not. Maybe this avoids overlap as well, because a periodicity of 3 means nothing will ever bounce back on itself exactly, right? Oh, shut up. So we advance to position 64 on both of our pixel readers. Then we say, give me an input from everywhere. Bloop. There's a red and a green, which are going to merge. And they'll be going either here or here at random, but I'm okay with either one. This doesn't seem right. I wasn't supposed to output this. They weren't both green. Do I just have this wrong? I don't think so. OE, I guess 15? Oh! Has a color component. I see. So yellow is green. Okay, so but I can just do the opposite. I can test for is there red? And if so, turn this conveyor off. So that's why there's no tester for like magenta. You can test for red and for blue, and if they're both true, it was magenta. I see. Well, or white, I guess. Or... Okay. So now it should detect some red and allow this to go into the garbage. And press B here, which we haven't wired it up yet, but in the future it'll trigger this creation. Yep, 107 gets thrown away. And I have this 107, like, just doing random garbage, but it doesn't matter. It's gonna pass through this color sensor, nobody cares. Eventually it makes it to the recycler, right? And it doesn't, importantly, very importantly, it doesn't overlap with... Wow, how... I'm not, like, noticing the tick at which... I guess that when you hit get input, these actually go forward on the tick they're produced. They don't wait here to... Okay, whatever, fine. But this 107 is here, and it sort of passes the one coming this way, which is exactly what you want. You don't want it merging. And this one goes the wrong way, but, like, nobody really cares. It combines here. Nobody really cares. Yeah, this is great. Eventually it makes it to the output. These U-bits kind of bounce around in the system for an unknown amount of time, but they're not causing any harm. And in fact, so this throughput is totally fine. I can do this. Which means there's plenty of space to fit this in here. And then output it, right? So either a bit I don't need this either. Nice. Either a bit comes this way or one comes this way. And we just have to wire this up to here. To here. Don't set it to 0 though. Set it to 1 something. 151, please. So we determined this 107 is not getting output. So we produce a 0. Or a hash. Well, produce 0 and then make it into a hash and send it out. And it's actually here just in time. It'll beat this one to the output, which is desirable. Errors 1. Okay, hang on. Why? Oh, this blue wire should not go through this conveyor, I suspect. Which is fine, we can do this. Errors 1 again, so... I can't quite... it's so... Okay, so which bit is the one we got wrong? It's the third one, right? Yeah. So let's look, then, at the third thing here. This. Set a breakpoint there, even, I guess? So far we've output 1 hash for the thing at index 1, or 0. We have another hash on the way out, but it hasn't made it yet. And so for this, hang on. Why is this pointer so far ahead? Like, why is this on 5 when this is on 3? That doesn't seem right. There's a breakpoint here on 3, but that's not the same as... No, this is right. They're advancing... This is 1 step ahead of this one, and this breakpoint maybe made me think it was at 3 when actually it was at 4 or something. Yeah, it's at 4 and this is at 5, which makes sense. I think. Maybe? I still don't get it. So we've read in the first coordinate. We use that to set these pointers to here, 120, I guess. And then we request the next bit from... Oh, this! No, this is fine. We've already read from 2 and 3, and we're now updating where 3 and 2 should read from, but we're not about to read from them, so it's fine. Okay. Oh, I suppose, by the way, we could save a bit of space like this. Okay. So we had green and red, and they mixed to become yellow, which still turned this off. Yes, it is off, and that's how this bit got here. That all makes sense. Meanwhile, we're saying, okay, 124, which is this. We're going to update everyone's read pointers to that. Now they are both updated down here at 124. I'm going to read a red and a green. Meanwhile, we're producing something to output here. The red and the green will merge and detect red, turning this off. So this goes up here. Great. Meanwhile, we're finally outputting the hash for the first bit. Now that we've determined... Oh, this bit's still just hanging around. But fine. Now we've determined where to read from. These are at 92. We're producing the output for bit 2, which is a hash. And so we've read the coordinate for bit 3, which is 92. And we're about to read in the character and the colors for bit 3, which are a greater than sign and at 92, they're both green. So why are you telling me I should output a hash? Okay, I must have misunderstood the requirements? If they're both green, send the character... Okay, I got a little confused. I have to write it at that coordinate. I forgot about that. So I was supposed to, or early on, I had written I had coordinate setters for 2, 3, and 5 here. For 2, 3, and 0, and I was like, wait a minute, I shouldn't be setting the coordinate for 0, but I should be setting it for 5. And the timing of that could be exciting. Because I'm pretty sure I will be going too fast to actually output that bit, right? Well, maybe not. Maybe I'll get lucky. Right, so the issue is... I mean, okay, there's one easy thing to fix. God, I can't copy and paste shit in this game. Is this. I can do that, and now make space here for setting 5. Like so, no problem. The problem is I don't think I'll be there in time. I have made my routing a bit easier though, haven't I? Well, it'll take up more space. You know, I actually would save space by doing this, wouldn't I? And it's not interrupting anything. It leaves me this little space as it's considered uncolonized. So the problem is I don't think I have this written in time. This guy is too far ahead of everyone. And I could probably fix that by just adding some delay, right? Like, this would probably be okay, but let's see how bad it is. Oh yeah, we're way too fast on this. I need... buy myself 3 ticks, I think. Kind of sad, but it is what it is, I guess. Yeah. I assume these things... OE21. Actually, what is the input order of these? Ports might be last. I'm not going to read the reference guide. Let's say I did it like this. Would that be okay? I think not. So this should be written to position 64? That is where my output pointer is right now. The question is this going to overwrite it to 124 first? It doesn't look like it. There's still nothing down here. So we should be writing to 92. No. We should be writing to wherever we were before. 134. I don't understand it. Let's just hit go and see. No, we found some errors. Okay. Well, I don't know if the timing is actually the problem. Let's just check. Oh, get rid of that breakpoint. I don't need that anymore. Well, maybe I do. Yeah, so this is correct. And it fits into challenge mode, and it's nice. I can't help but feel we could do a bit better. This is just sort of sad. Really reduces the throughput. How are we looking on the charts here? Oh boy, more story. Data floods in, a torrent of information. The nodes whisper secrets to me. I'm changing. Your solutions are unlocking new potentials, new capabilities. I'm not just an administrator anymore. But it's not enough. You have to put more of yourself into the machine. Multiple system failures. Okay. Great. So we're still actually a little bit above average on cycles. Doing great on icons and space. Which makes sense since we fit into this tiny, cramped little area. But I think, for example, I could speed things up a bit. Maybe? What do I think I'm going to accomplish by moving those over there? I still need a big gap in between reading a bit and setting the right pointer because it takes so long for the bit to get there. So I could request inputs 3 and 2 separately sooner. But then they won't match up with input 1, which is here, so I think this is just a bust. Let's just leave it alone. Be happy with meeting the challenge and not try to squeeze out more cycles or something. Less space. How long was that? That's probably an episode, right? Yeah, 52 minutes. Cool puzzle. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.